Have you already hacked the game? Or,
No,
Oh,
I'm not
you-
going to.
All right, all right. So limit comparison test is actually pretty easy. Not super easy, but I think it's easier than the other one because the other one is a little bit more confusing.
What's the other one?
Direct comparison test.
Oh.
Direct comparison is making something out.
Yeah.
Yeah, this one you had to do, but it's more direct. Like it's more. I don't know. It's more.
This is more direct than the direct comparison test, guys. Don't worry.
Yeah. I don't know. I personally not big fan of comparison tests, but they're okay.
I'm not ready. We wrote an essay yesterday, and honestly, I slayed.
Okay, so limit comparison test is pretty easy. So limits comparison test. I do. Trevor's here. What's that guess? Of course, Lemon. Emily's not here. Even though she had to stay here. Oh no, she don't. A_n is greater than 0. B_n is greater than 0. And so you compare the ratio of A_n over B_n. Why you compare? Because if they compare and they equal to a finite number, that means they are pretty close to each other. If they are close to each other, if the series you compare to is diverge, then the other series is also diverge. If it's converge, then the other series also converge.
Because infinity is pretty close to infinity. Yeah, that makes sense.
L
He's called you an L.
where
L is.
L is finite and positive. So it has to be finite and positive. Then
finite isn't like it's an actual number.
yeah, it's some arbitrary number, but it's finite. It's not infinity, right? If it's infinity, then it doesn't work.
It's very non-finite.
Then L. Oh no, sorry. Then summation of n equal to 1, infinity a to the n,
What do you mean?
and summation n equal to 1. Will, can you stop? Bn. Either both converge or both diverge.
What? Oh.
Okay. So like last time, you'll compare a series that you know of, but you don't have to determine which one is bigger, which one is smaller. Sometimes get kind of confusing. So I think in this particular part, I think limit comparison are a little bit better and also more effective on more complex series. So limit comparison, I feel like it's a little bit more powerful and is more obviously. So they can either be both converge and both diverge. But you still have to come up with the series that you're comparing with. Which is most of the time, people think that's the hardest part. But
Yeah, that's the work that you have to do. Yeah.
don't overthink it sometimes. Now, a lot of time you can use multiple tests.
Is this an example right now?
Yeah, this is the example.
Okay.
1 over a to the n plus b. And a is greater than 0, b is greater than 0. So we know both a and b are positive values. And I think we have homework question like this. I think it was 3n plus 2.
That's very true.
Is that true?
Yeah.
Okay, so now you can use this by comparing on the homework you can compare to 1 over n, which is diverge. So this is the things that we compare with. So this is the things that we had to come up with. Hopefully this one's pretty easy to come up with. This is diverge.
1 over a to the n. What does that mean?
Which would also be diverge. Which is diverge.
So this one's diverge, right? So we compare, we are use limit comparison. So what is limit comparison? LCT, limit comparison test. And what we're comparing with is the original function. And we're using this. So we're going to put 1 over a to the n plus b over 1 over n. And if this n approach infinity, it go into a value, a positive value, then it's gonna be both diverge. So be an plus b, and this one's n over 1. So it's equal to n over an plus b when limit n approach infinity. Now you can choose to do L'Hopital rule, but I choose to do this rule because I kind of like this one because I don't know, this is my, I don't think it is really complex. So be a plus over b to the n. This going to 0 is equal to 1 over a to 1 over a. Now since we know a is a positive value, and 1 over a is still L, right? There's still L. If it's L, then this one is diverge. Therefore, limit n approach infinity of 1an plus b is equal to diverge. Because we compare with this. Now you do have to write down using what? LCT? LCT is limit comparison test. You can use a DCT as well.
You have to come up with an equation exactly like the DCT. Yes.
Right, so you're using both.
No, you use this one's a limit comparison test. Now DCT
DCT would be finding out whether whether the other one converges using like another test.
Yeah, but you have to. The other one is kind of more complex because you have to figure out if the larger series converge, then the smaller series must also converge. If the smaller series diverge, then the larger series must also diverge. So you have to compare that. You set up the inequality. So that is a little bit hard to decide, right? Because sometimes it's kind of confusing. If you're adding 1 on denominator, are they greater or smaller? Sometimes it's harder for me to think about it. For example, 1 over n squared and 1 over n factorial. They are, it's kind of hard to figure out which one's bigger. And factorial is bigger, good, because we just know that. Now, in this case, you just have to divide and reach infinity. If equal to the number, then if that series is diverged, then ours is going to be diverged. If that series is converged, this series is going to be converged.
So it doesn't matter what the equation, whatever equation you come up with, it doesn't matter if it's greater than
Okay. So what we're going to do is compare this one. N equal to 1, infinity, square root n over n squared plus 1. Now, in this case, what are we comparing with?
a P series then.
Well, which one? Like, what series I'm comparing with? Like, if you want to name a series, what would be the series I'm comparing with?
1 over 3, n to the 3 over 2.
What is it?
1 over n to the 3 over 2.
Why is that?
Because it's, n squared divided by n squared.
Okay, Will, what do you think?
That means I got it wrong.
No, because Will's distracted. So
What's the question again?
yeah, exactly.
Wait, I got it.
What are we comparing with?
N to
We
the
would
3 over 2.
n to the 3 over 2 is wrong.
Ooh.
No, it's a part of what I said, yeah.
It's a part of what he said. But if you pay attention to here, then you are comparing to square root n over n squared, and of course you can simplify that. So 1 over n to the 3 over 2.
Yo, and then you can use P series. Yeah.
Ah, there we go. So we're comparing with this. So this one, so we are compare. So LCT compare with this, right? Summation of infinity n equal to 1, 1 over n to the 3 over 2. We know this one is converged. So if this divided by this and reach infinity is converged, then this series is also converged. So what we're going to do is we're going to do limits. N approach infinity. Basically, why we divided that? We divided by to see which one's speed. Are they close to each other? If they close to each other, then it's going to equal to some type of constant. If they're not close to each other, right? Then we're not able to decide. But if they closer to each other on the series we compare with, that
What is
series
zero?
converge, then this is also converge. If that series diverge, then this series also diverge.
What if the thing you get is 0 with the limit over 1?
And we're gonna talk about those in a second. But usually you're not gonna have that. Square root n over n squared plus 1, and we compare to 1 over n to the 3 over 2, right?
Wait, but what happened to the one? We did square root n over n squared. We didn't do like square root n.
No, oh, this is the new equation that we're comparing.
Oh, that,
It-
okay,
it-
okay. I'm just confused why we can't do direct comparison test. You know, it's like, you know what I mean?
This one's more powerful and it's more direct. You don't have to debate which one's bigger, which one's smaller. Long as you know, like before, even like sometimes this, we still get inconclusive because it's a little bit small and diverge, but you still have to run a separate direct comparison test,
Well,
right? You have to
you
run,
can't prove
for example,
convergence
natural.
with the DCT, but you can with the LCT.
This one you can. You can just say like, you can use like.
But what if that was n squared minus 1? You couldn't do DCT.
Whoa. So if I want to do something like figures, I did like.
Yeah.
So, but then you got to come up with two equations instead of one. You had to come up two series you got to compare to. If one series doesn't work, you got to come up with second series. This one just have to come up with one known series, and if limit approach that's why they say limit comparison test. You have to limit and approach infinity. Now this one's gonna give you a result right away without doing the second test, because if you do this, you'll find out if you're really good at algebra,
an n squared over
which is
n squared plus 1.
limit and approach to infinity. This one's gonna be n over n squared plus 1, and this one's gonna keep change flip. It's gonna be like this.
Whoa.
So that'll be n squared over n squared plus 1, and limit n approach to infinity. Now this one is equal to 1, 1 is equal to L. L means LCT says limits n, oh no, sorry, not LCT, but it's LCT, but a summation of n equal to 1, infinity square root n over n squared plus 1 is also equal to converge, because due to LCT. Because you compare of 1 over n3 over 2. n3 over 2 is p series, and we have to say this is p series, that's why it's converge.
So we just.
If you, for example, you just put both all the things over n squared, because that's the biggest factor, right? Well, okay, but you know how it's like if it's x squared over x squared plus 1, you would put all the terms over x squared. You just put that over
Yeah, so 3 over 2 would be
So
less than.
Got
and
Yeah.
so
Okay,
converging
I
and
understand how we got to the like n squared over.
Yeah, and besides, even it does work,
The one.
sometimes you take 2 try to work. This
why
one
is
you
that
take
one
one
random?
try. For example, that one,
So if it's undefined.
natural log of n over n plus 1. The first try I did was natural log of n over n.
Diverging.
And we figured out that doesn't work. And then we had to say, okay, well, since that's diverge and this is small and diverge, the series is still possibly diverge or converge. So not definite answer. So then you compare 1 over n plus 1. So now in this case, the next case is going to be more complex. Now this one, I don't think direct comparison can do it. Okay, so direct comparison probably cannot do this one. At least I don't know of. Is this one 4n to the 3 plus 1.
Oh, I thought it was the n.
Okay, so you compare 2n.
Well,
Wait, what's on the top?
can you say exactly what's on the top?
It's n times 2 to the n
Okay.
over 4n cubed plus 1.
Wait, are we doing this one on our own?
No, I'm gonna kind of guide you. But this one kind of had to think about two things for a second. So where is the most interesting things that we will compare with? If we want to simplify everything, we will compare this here, right?
Yeah. Because the one doesn't.
and the 2 cancels out. And then
And this 4 probably doesn't matter either. So I'm just gonna compare with this.
that's all.
4 just 4 times, not big deal.
1/4.
Yeah, 1/4 doesn't change anything. So then you compare with n over n to the cube and 2 to the n. So you can simplify that to 2n n squared. Now, do you know this series converge or diverge?
Yes.
It diverges.
Why?
2 to the n is way bigger than n squared.
True, but what other way I can test it?
Yo, the
I'll have the rule
Which is the
or
n
n-term divergence test. right?
N-term test, like using hospital.
Yeah, because you have to take it. You have to limit n approach infinity.
Yeah.
If I say limit n approach infinity of 2 to the n over n squared, this one is going to be infinite over infinite. Then you have to take a derivative, so be natural log of 2 to the n over 2n. And if you do it again, it'll be natural log of 2 times natural log of 2 times 2 to the n over 2. Now, if I reach infinity, what will happen? It's going to be diverge, right?
Yeah.
So if this is diverge, then you say, okay, so we know for sure this series diverge, which is compare this. Hopefully, they don't equal to 0. Hopefully, they equal to some type of constant. So now we're going to say, okay, LCT comparison, compare with summation of n equal to 1, infinity, 2 to the n over n squared.
Well, you could just multiply times ln of 2, like when you derive that.
Yeah,
It's not like product rule or anything.
no, like I said, remember that we had to take a derivative of this, y equal to 2 to the
No,
x.
I understand you did it, but like, I would just ln of 2 is a constant. My bad. Yeah.
Are you sure?
Yeah.
So if I do ln of y, ln, so it'll be ln of y, x ln of 2, remember?
Yes. Yeah. We did it earlier.
And then if we take a derivative, y prime over y equal to ln of 2, and then y prime is equal to ln of 2, 2 to the n, 2 to the x. So those are from before. So then okay, so then that's, see, this one's more complex. So direct comparison is going to be kind of difficult to see. Now limit comparison is going to be way better. Limit comparison, just say, okay, well, let's divide this. And the reason why I want you to learn to divide this, because ratio test is the same way, and ratio test is like a most important test. It's more important than any of those tests. So we
Does the LCT compare what?
compare with 2 to the n over n to the square. So hopefully they reach equal to a constant. So if I do that, then it's going to be n 2 to the n over 4n cubed plus 1 times n squared over 2 to the n. So the nice thing is this will simplify down very, very nicely. So it'll be n to the 3 over 4n to the 3 plus 1. If limits n approach infinity, what am I going to get? 1/4, therefore, is diverge, because the other one's diverge, this one's diverge. See, this one don't have to compare two series. A little bit more algebra, and also can deal with more complex situation, and then actually can simplify, come down really, really nicely.
Give me 1 second.
And this one can actually prove convergence, unlike the other one.
We're just proving that.
The other one we also prove converge or diverge.
The DCT, if it approaches 0, it's either converge or inconclusive. So you have to do another thing.
Oh, okay.
Yeah.
Because of that.
Yeah.
DC, no, you're talking about n divergent test. Divergence test.
You're talking about the one that has like CPD.
Yeah.
Like for the previous one.
Yeah, you're an idiot.
Okay,
Yeah.
that makes sense.
Be nice.
Damn, I just took it too.
No,
You scare Michael here.
me personally, I want to do this
I can't take that thing.
I didn't know that you were here. I thought you left.
This is school.
How's the math looking?
Isn't this way better than mental health?
Cool.
Yes.
That's hurting mental health.
No.
Next time you're having a panic attack,
Just
Start doing captions.
I feel more stressed out when we're actually doing the mental health lesson.
They suck so bad.
Yeah.
They're like awful.
For me, I just think
Like,
it
you need to make more
remind
time for yourself.
you that you have problems.
And you're not.
Yeah,
You're
so
not
kind.
taking care of
I don't
it.
need the reminder.
Yeah, you don't need to remind me I have mental health. If you don't remind me, I forget about it, right? If you keep on reminding me, I don't know. Anyway, this is on recording, so I probably gonna get canceled.
Damn, that's crazy. Are we at peace now? Are we done?
Yeah, I'll give you homework.
Yes.
I am so real that I would say anything I say in real life. on
Wait,
record.
what is
But
I do that too. That's me.
Yeah, but you just said you won't say it because you're being recorded.
No, but I already said it though. It's already on record.
um,
It's even worse. Like if people want to cancel me, they'll be like, "Yeah, just watch this YouTube at 43 minutes and 32 seconds."
like, what if you get zero?
Like if one day I'm running for politician and have so many canceling material, I have to cancel my YouTube channel.
That's just like the question.
I have to delete my YouTube channel.
So
Neither is
he
objective.
just said hopefully that doesn't happen. That's what he said. Yeah. Well, what time do we leave?
That's what you sound like.
Cindy, do you know what time? Oh, yeah, I got you.
Because if we're smart about this, we can finish all the homework.
No.
I'm not smart about this.
But you do homework way faster than I do. It's like not
Yeah,
even funny. Yeah, it takes me hours.
It's because I dread doing it so much that I don't do it slow.
Okay, I'm gonna airdrop to you. Okay.
We got 40 minutes.
Yeah, I'm gonna airdrop to you.
But also me dreading it causes me to never start doing it. So it's like
That's me with essays.
I'm actually good at. I don't know why, but I think I just like got good at writing essays at one point. It's like when I stopped paying attention to the rubric and just started writing based off of what I thought sounded good, and then I got good grades.
My thing is on.
I pressed accept, and then it was like, too bad, it doesn't fit.
I'll send it in the group chat.
Whoa, what's
Up,
going
dude.
on?
It's like
Yeah.
a flare.
I think fighting type is strong.